before told me that probably the confusion before, where I was confused with people not raising their hands, might be because people don't usually use IPsec within their ISP infrastructure, per se, except for remote VPN access. But again, you are configuring IPsec. And what I have found in the last few years is that there's so much confusion because there's so many different ways that people will configure IPsec or the terminology that they use, that I try to, unconfuse people. At least say, here's what the spec actually is. Here's what terminology people use that essentially mean the same thing. Okay, and that will be clarified in just a couple of minutes. One thing that I do want to point out, and if you guys have your laptops and want to type this or go check out the site right now, there is the VPN Consortium. Okay, it's run by Paul Hoffman, and you can get to it by vpnc.org. If you look on that particular site, there, somewhere on the right-hand corner, there's a whole bunch of other places you can get to. And one of them, I'm trying to think, it's something like implementation examples or conformance examples, something like that. Click around. But what he basically did about a year and a half ago was he decided that, it's so hard, like everybody has these different configuration requirements, and he wanted to do some kind of interoperability testing. But, why should he spend days trying to figure out how to configure all these different devices? So he set up a sample scenario, which is basically two gateways talking to each other, doing tunnel mode IPsec. And what he had was most of the vendors that are part of the consortium should then send in configuration templates in terms of how to configure to this specific scenario. And why that's really useful is that if you have these different devices, then at least you can figure out, how do you configure your keying, your IKE phase 1, your IKE phase 2, and what is the terminology that they use. So again, vpnc.org, and there's probably about 15 vendors on there. And actually a year and a half ago, I did the NetBSD configuration for him, installing Raccoon and all that kind of fun stuff, because I was just starting to play with a bunch of stuff. So it's very, very useful if you're starting to configure IPsec, or you've kind of been holding off because you haven't had the time yet to figure out how to configure it on different machines. So anyway, okay, IPsec. Whole bunch of RFCs that define it. What does it provide? So at the network layer, right, it provides confidentiality, and there's a whole bunch of algorithms to choose from. DES is still mandatory within the standard, but basically a lot of people use triple DES. Okay, most implementations have that. So even if you look at what the standard does, it's kind of interesting because a lot of the must and the algorithms that they have to use, and maybe some people use that as the default, may not be the best algorithm. And my point, my perspective on security in this day and age is that use the strongest algorithm, the largest key, and if you run into a performance issue, then start to go lower. But if you do not have a performance issue, I don't see any reason why you do not use the most secure, strongest algorithm and the longest key. And if you're running OC, I don't know, 12 links, and you have a lot of data, and you might have performance issues if you're actually encrypting everything. Yes, that will be an issue. But if you have T1s, T3s, and you're using hardware encryption, you may not have any kind of performance issue. Just pick the strongest algorithms. And I will later have some examples of the parameters to pick. And again, within IPsec, what is really a pain in the butt is that most vendors have different defaults. So you're going to have to change them anyway if you're in a multi-vendor environment. So, all right, so IPsec provides confidentiality and then data integrity and source authentication. There is anti-replay protection, but it's optional. So the sender can say that, yeah, I want to provide anti-replay protection, but the recipient can actually ignore it. Key management, IKE is used for key management, and it negotiates sessions and establishes them. The sessions are rekeyed or deleted automatically. Secret keys are securely established and authenticated, okay, using Diffie-Hellman. We discussed that earlier. And the remote peer can be authenticated using varying options. I was just talking to somebody a couple minutes ago. We were talking about manual keying versus automatic keying. Automatic keying is IKE. Okay, manual keying means that you are actually configuring your SHA and your MD5 and those parameters, you know, the whatever 40-bit values. And if I talk about manual keying, that does not equate to pre-shared keys. Okay, that's something completely different. So for IPsec, you can use manual keying where you enter these large god-awful strings and then, you know, determine what your keys are for encryption and for data origin authentication. Unless you are very well versed with the algorithms and have, you know, maybe less than 5 devices that will talk to each other with IPsec, you should not use that, and you should really use IKE. So a security association, an SA, is very integral to IPsec, and basically it groups elements of a conversation together. And what it does is basically defines a group of parameters for the authentication algorithm, the encryption algorithm, the lifetime, how long a session is valid for, and that you use certain encryption keys, and also whether or not you're using transport or tunnel mode. And typically it maps from a host to a gateway, and from a host or a gateway, it maps to a particular IP destination address, and you can define whether or not you use authentication only or if you have confidentiality. And I have some slides that describe more about AH and ESP, so these unfortunately have not been defined yet here. A SPI number, it's just used locally. Okay, this is not really something that you need to know, so I'm just going to skip that. IP traffic selectors, this is important. You may not want to encrypt everything. If you have very large links and you do run into some kind of a performance issue, right, I mean, you might just say, you know something, the only traffic that I really care about providing confidentiality for is maybe my telnet traffic in between routers. Okay, because some people are doing that. They are, instead of using SSH, okay, they are using telnet protected with IPsec. Because what you don't want any of your password information to go across any wires in the clear. So even though I said do not ever use telnet, well, there's a caveat. If it's protected, okay, in some kind of a secure tunnel, i.e. IPsec, then it's okay. Now the problem is most people don't do that because IPsec is a nightmare to configure. And even within certain big vendors, if you have different IPsec devices, they may not interoperate with each other, right? Even out of the box, they might have different defaults or things like that. So IPsec is a real pain in the butt because there isn't really an interoperable, easy way for people to get IPsec to work. And vendors are working to make it easier, but it's still hard. But so anyway, selectors for traffic matches. You can define what traffic you want encrypted. So maybe you just want telnet or SNMP traffic encrypted, right? So you can actually define that. So here are the 3 main components of IPsec. There's something called the AH, and that's the authentication header. And essentially what that does, it provides for data origin authentication and integrity of the packet, so that if you're sending something from a sender to a receiver, the receiver can be more or less ensured that the data hasn't been altered in transit. Now, ESP was originally defined to add confidentiality. So the thought was that you would use AH for your integrity and then ESP for confidentiality. But As people started using the standard and implementations, came to market, it became very clear that things are just really difficult and convoluted. And so what people did was they modified the ESP standard so that you can actually do authentication. You can do null encryption, which means you don't provide for data confidentiality, but you essentially provide for data origin integrity. So some people want to do away with AH because they think that it causes too much of an issue. It makes the protocol too complex. And what most people do is they actually use ESP. So you also, and then the third portion that's important is IKE, which is the Internet Key Exchange. So it's how you actually derive your session keys. So with the AH portion, okay, the authentication is implied to the entire packet, with the exception of some fields that get modified in transit. Right, so if you think about the IP header, there's fields like the flags and an offset and type of service, and as you traverse many hops at the network layer, they can get modified. So these can't be used as part of the authentication check. So again, this will just be an FYI if you really care what the header looks like. So AH, again, it provides for just basically integrity check that data hasn't been modified and that the sender is who you think it is. So with ESP, you either encrypt and or authenticate each packet. The encryption occurs before authentication, so that you can actually encrypt and then you can authenticate, and as it passes different hops, you can then verify the authentication. So again, here's an ESP header format. It's more of an FYI. I don't think it's necessary for me to go through that. So here's an example of how packets are altered if you're just using plain, IP packets, and then if they're altered for AH in transport mode. So before applying AH, you have the original IP header, you have your transport header, either TCP or UDP, and then you have your data portion. So after applying AH, you still have your original IP header. You then have, following that, the AH header, and that follows then the rest of the packet, your transport layer, and then your data. And the fields that aren't a part of the authentication are the 5 listed there, which is a type of service, TTL, header, checksum, offset, and flags. Okay, but everything besides those fields are authenticated. So for ESP, okay, essentially this usually adds confidentiality. So where I say encrypted, okay, it's encrypted for confidentiality. And then the fields below that I say authenticated, that's what's authenticated. So when you're using ESP, the encrypted portion is your transport layer and your data, and also the little piece of the ESP trailer. And what's authenticated is also the addition of the ESP header. All right. Now, IPsec can be used either in transport or tunnel mode. Okay, transport mode essentially was meant for a client to from an originator to the recipient. And tunnel mode was essentially created in scenarios where it would be gateway to gateway communication. So the first scenario that I just showed for transport mode would be, for example, if you wanted to use from router to router, right, telnet protected with IPsec. But if you have a network behind the router and you're going to another piece of your network, let's say a customer network, and they have a VPN and they have a gateway, then what you probably want to do is you want to do tunnel mode IPsec. And so this is what the packets would look like if you're using tunnel mode IPsec, where again with using the authentication header, you would authenticate everything, even the new header that's added on. Because remember, if you're tunneling, right, then your new header would have to incorporate which of the gateway IP address is the source and the destination. It's not the actual source and destination, right, of the packet itself. And then this is the same thing for tunnel mode if you're doing ESP. But that's, that's just sort of FYI. The Internet Key Exchange, IKE. IKE, I think, is the most confusing thing in the world, right? And they've now finished IKE v2. It's very unclear whether or not people will actually ever use IKE v2. And the reason why is because as people started doing the analysis of what does IKE v2 buy you over IKE v1, it doesn't really buy you very much. So, if you're talking to your vendors and you're trying to figure out, I just figured out IPsec, I don't know, do I upgrade my image just because, it now includes IKE v2? Be very clear in terms of what it buys you and what vendors are doing, because from my personal talks with people, it looks to me like IKE v2 is more or less going to be a checklist. Okay? And most people will just end up using IKE v1. So just an FYI, be very clear on that. Don't listen to marketing and FUD, but really try to understand what IKE v2 would buy you. So the thing with IKE, right, and why it's so confusing is because there's two phases to it. There's IKE phase 1 and there's IKE phase 2. Phase 1 IKE, right, some vendors call it IKE. Some vendors call it ISA KMP, right? They're the same thing, it's IKE phase 1. And I think the reason why the controversy or where the problem came in is because ISA KMP is a framework for how to do the Internet Key Exchange. IKE is a specific implementation of ISA KMP. So as an engineer was coding up, the Internet Key Exchange stuff, depending on what their thought process was, somebody said, okay, it's ISA KMP. Other people said it's IKE. So an ISA KMP tunnel equals an IKE tunnel equals an IKE phase 1 tunnel, right? Phase 2, also there's people that either call it IKE phase 2 or they call it the IPsec tunnel, right? And so what IKE phase 1 does, IKE phase 1 sets up a secure tunnel so that two peers can then have a secured way of negotiating the keys and the algorithms that they will actually use to provide authentication and confidentiality for their data, okay, which is then phase 2. And let me go through that a little bit more. But I tell you, if once you just understand what the terminology is, I think things become a lot clearer. So overview of IKE, here's a picture. So you've got two IPsec peers, and traffic's coming in from the peer on the left, and you want to create a secure tunnel using IPsec to then communicate to the IPsec peer to the right. So what happens is you go through IKE phase 1. So there's a number of parameters that you can define. You can say, okay, I want to provide data confidentiality using either DES, triple DES, some kind of a secret key technology. Okay? You also can do data origin authentication. You can define either SHA MD5. You can define a parameter which is the Diffie-Hellman group, okay, which is the mod P group, which basically means that, okay, how big are my prime numbers going to be? If you will recall, way back about an hour and a half ago, when I showed the Diffie-Hellman slide, right? A device has to come up with two numbers. There are two prime numbers that it then sends to the other side. Diffie-Hellman, the two common sizes for these prime numbers are 768 bits and 1024. 768 bits is the Diffie-Hellman group 1 equals mod P group 1 in some devices. Okay, the 124 bits is, Diffie-Hellman group 2 mod P2. Okay, I don't know, I don't understand the people that came up with this terminology, but, essentially in one router you configure mod P group, the other one Diffie-Hellman group, and I don't know, the defaults vary among different devices. And so the first thing that you need to do is really figure out for yourself what is it that you want to use. Okay, and I will have a slide later that says, this is typically what I just configure for everything. So you have your Diffie-Hellman group, you have your authentication, your integrity algorithm, you have your confidentiality algorithm, and you have your lifetime. And usually that's what you configure for IKE phase 1. And then you have a secure tunnel. Now you go ahead and try to figure out, all right, well, what do I want to do to now establish, how do I want to encrypt my traffic? Right, and again, you define which authentication algorithm do you want to use, MD5 or SHA-1, which encryption for confidentiality algorithm do you want to use, triple DES, AES, DES, Blowfish? Do you want, a different lifetime, and which Diffie-Hellman group? So you have to define these things twice. And then for the second, once IKE phase 2 is completed, now you've got your IPsec tunnel where your data is going to be encrypted. All right. Typically, you don't have to configure this. IKE phase 1, okay, equals is a KMP equals IKE. There's two ways. There's two choices here: main mode or aggressive mode. Main mode it has more messages, and it's typically what's used. So it does a Diffie-Hellman exchange, and it does an authenticated Diffie-Hellman exchange. And so here's a slide that kind of shows what happens in main mode. So you have 6 messages that get sent across, pairs of 3 messages, request response. So you have an initiator and a responder. So what the initiator sends the first IKE message, which basically is a proposal saying that here's the algorithms I want to use, here are the key sizes, here's my lifetime, blah, blah, blah. The responder then sends a message back saying, yep, I accept your essay. And then both of them, after this first initial request and response have been sent, they both have enough material to compute the Diffie-Hellman shared secret and derive some keying material. Oh, no, sorry, time out. What happens is that after the first set of exchanges, you send the essay proposal, and the responder then says back, yep, I want to use, the MD5 algorithm, I want to use triple DES, I want my lifetime to be 8 hours. The next set of exchange is you do an authenticated Diffie-Hellman exchange. So you're trying to derive a shared secret. So you send the Diffie-Hellman public value and a nonce, which is simply a random number, and then the responder replies with a Diffie-Hellman public value and a random number. And now you have the information that you need to compare to derive the shared secret. And so once you have the shared secret, you then have, you protect the IP identity by sending the authentication material and the ID, and then you get it sent back. And this exchange is encrypted. So with IKE phase 1 main mode, you have an authenticated Diffie-Hellman exchange. Okay, so you're fairly ensured that the public values that you're sending actually came from the person that you think it should come from, and the identity is encrypted. We talked about Diffie-Hellman, so I'm not going to use that. So for aggressive mode, right, which is the alternative for doing IKE phase 1, you only have 3 messages versus 6, and you do not have any identity protection. And it's optional, and usually people don't really implement it. So really, I wouldn't even worry too much about it. So for IPsec, if you're configuring it, just think, okay, you have IKE phase 1, which is also is a KMP, and you need to define some parameters for, you know, how you want to do your encryption, and you usually use main mode. And so once you have this secure communication tunnel set up, now you then negotiate the parameters for how you want to actually authenticate and encrypt your actual data, you know, via the IPsec tunnel. And that's essentially done with something called quick mode. And once quick mode is finished, what you end up is with two security associations. So a security association is unidirectional. So for any IPsec communication, you have two unidirectional security associations. And it's funny because, you know, you can have different algorithms. So if I'm communicating with you over there, I can just say, well, I want to use, you know, SHA-1 for authentication and DES for encryption. And you could potentially want to use MD5 and maybe AES for encryption. But, you know, that's typically not done. And, you know, you basically use the same algorithm. But the flexibility is there. So here's just a picture drawing for what happens when you do IKE phase 2 quick mode. So you send the first message to the responder, and you send some keying material and your proposal for what kind of algorithms you want to use. The responder validates message 1, right? Make sure that, okay, it is indeed from you. And then the responder sends back an authentication and keying material and the accepted proposal. So, yep, you know, I do want to do SHA-1, and yep, you know, I do want to use AES encryption. The initiator validates message 2, make sure that, you know, it is indeed from the person I expect it to be from. Then it sends a hash for proof of integrity and authentication. And finally, after the validation of the third message, the keying material is computed. So as a summary for IKE, right, you basically negotiate the parameters to establish and secure a channel between two peers. You provide mutual authentication, so both the initiator and the responder are authenticated. And then there is IKE v2. Again, I'm not very clear how much it will buy you. IKE v2 was very largely created because once people started using IPsec, it became clear that for many remote access scenarios, there were things that weren't considered in the first part of the spec. For one thing, how do you do user authentication? Right, so most authentication is done thinking of devices. And so if I am a remote user and I am coming into a corporate network, or, you know, my NOC or something, then, okay, you know that this is my laptop, but you don't know that I am the one that has my laptop. Right, so within remote authentication, there had to be a way to define or provide for mechanisms to actually authenticate the user. And typically what's done right now is you actually authenticate both the device and the user. So there were extensions added to IKE v1 to do that. I think mod P is what one of the extensions is called, or XAuth actually. XAuth is the extension that provides for user authentication. And even though that's not a ratified standard, it's been widely adopted. And then another issue with IKE was, all right, you know, there's a lot of DHCP out there, and a lot of ISPs are giving out addresses, you know, to folks. And so these addresses change. And so how do you actually, you know, do any kind of a tunnel mode using IPsec when you're authenticating the IP address, but it's changing? Right, that's an issue. So that's where, you know, they had all these extensions that they were then defining for IKE v1, and then instead of having all these convoluted extensions, they decided, you know, we should really create an IKE v2 and then incorporate all this. So, all right, so you had the dynamic address issue, you had the device versus user authentication issue, and of course our dear friend NAT, right, NAT and PAT. So there's a lot of environments that use network address translation. I used to find it really funny when some vendors used to market NAT as a security mechanism, right? Oh, well, you don't know my IP address, so I'm secure. I'm like, all right, you know, that's a little bit security, you know, through obscurity. But I think most of us are using NAT in some way or another, and NAT breaks a lot of things. And in IPsec, it's a very large issue. And so there's been a proposal that's been ratified, and it's called NAT Traversal, which helps solve some of the issues. All right. So if we look at some of the problems that exist, right, so you've got two different areas of a network, and they're trying to talk with NAT and PAT. What happens is, if you look at the first arrow there, you have a private source address, and it's converted to a globally unique address. Right, so then the corporate network, the remote router, replies to the IP address, but the destination IP address translates to private IP address using port numbers to help with demultiplexing. And there's a lot of issues with what if the tables run up, you know, and just keeping track of who are you translating to. So here's a slide that shows what in the IPsec working group they've come up with for transport mode ESP packets. So NAT traversal doesn't work for every single IPsec scenario. Okay, it's mostly meant for transport mode. And because of the fact that most people thought, well, AH is probably going to go away and not people use it, it's also only been defined for ESP, so the encapsulating security payload portion. So this just kind of shows you what the packet would look like and where it's applied. Now, I have such an issue with IPsec because no matter what you do, you're going to have to spend some time trying to figure out in your own environment whether or not any two devices that aren't the exact same devices will actually speak IPsec appropriately. Okay, because if you buy two devices that maybe one is a client and one is either a switch or a router or firewall, and you're speaking IPsec to it, even if it's from the same vendor, unfortunately it may not interoperate, right? And so we run into the, okay, so what do we do? I mean, I think this is one of the reasons that people have been shying away from IPsec. And the only thing I can say is that, you know, I think people do need to start using it. And I think that some, like websites like VPNC.org, who's providing some useful input for how to actually do sample configurations, you know, is very useful. So, anyway, so that's my spiel on IPsec. And again, if some of you have any practical experience or have actually looked into whether or not you want to use IPsec for your routing authentication versus MD5 authentication, I'd be very interested in that. Because I've been talking to somebody that I know from Cisco, Dave Ward, who actually had a draft out on BGP, right, and to actually do IPsec authentication. And he asked me whether or not he should continue. And my response was, well, you know, I really need to think about what the trade-offs are between doing MD5 authentication versus using IPsec for authentication. And the one trade-off, the only one that I can really think of that would be a big proponent is the rekeying issue, that it's a lot easier to actually rekey using IPsec with IKE than if you're using MD5. So I'm just asking people, like, if you know, have practical experience or have thought about it, I would love to discuss it with you. All right. Link layer security, I'm going to kind of run through this because I want to get more into the architecture piece. But with link layer security, a lot of people are using L2TP. And if you're using L2TP And if you're using any kind of VPN, people are also implementing MPLS VPNs. I hate when people say that MPLS VPNs are secure. Okay? Because MPLS VPNs are only secure if you actually put some kind of security functionality in with them, i.e. meaning that you apply some kind of firewall strategy as well as probably implementing IPsec. Because any layer 2 VPN, be it ATM, frame relay, L2TP, MPLS, pick your flavor, is not secure. Okay? You have to actually add security functionality on top of that to have a secure VPN. You know, I mean, I'm a very strong believer in that people need to do security right. To do security right, you need to understand what is secure and what's not and what your vulnerabilities are. So just something that I wanted to point out. And here's that statement, okay? Very important. So now we get to the more interesting part, I think, which is, all right, so now we've got our networks, right, and we've had to implement some kind of security stuff on them just because, well, you know, we're all authenticating something. We all need access to devices, and, you know, we're all trying to figure out, well, what to filter. So what this section is going to go through is sort of my version of best practices, which quite frankly hasn't changed in the last 6 years, not very much. And I forgot to mention, I will just because I can, but I wrote a book on security. And this is the second version. It just went to print 2 weeks ago, right? My first version came out in 1999, right? And in 1999, I had in there filtering, I had in there, you know, using your encryption schemes, I had in there, I mean, for if you're showing configurations, I had in there, you know, filtering, I had in there all kinds of stuff that I was very surprised and somewhat shocked a year ago when I started looking at stuff again that people hadn't implemented. And I'm like, this is not new stuff. I mean, this is all the very basics of actually securing your devices, and nobody's implemented the functionality that has existed in there for years. Right? So one of the things that I kept thinking about, like, why? And I thought, well, it's probably because it's very low on the priority list. And as in the last couple of years, it's become more clear that infrastructures will get attacked, and, you know, there's more money being lost because of actual attacks, that I think people are paying more attention. And I find it very interesting. I think a lot of the things that you will hear today, you will also hear tomorrow and Tuesday as people talk about this is what you need to do to secure your infrastructure devices. And, you know, these things have really existed in most of the vendor implementations for years. So I'm, you know, I'm hoping that people will become more aware that this is a real problem. And even if you haven't been attacked today, something Rob Thomas keeps saying, and which is an important point, is that, you know, you may think that you have not been attacked because it hasn't happened today, but your infrastructure device might be compromised. Somebody knows what the password is. They just haven't used it yet. You know, so, you know, don't sit in this, like, you know, unreal reality world of, nope, didn't happen to me, nope, I'm secure. Because more likely than not, you know, unless you really put some thought in it, and unless you're constantly auditing your devices, something not so pleasant is going to happen in the near future. So, and, you know, as you get more involved in security, I think people become more paranoid, at least I do. So, you know, I might be more paranoid than most, but just, you know, be careful out there. So with security, the thing is, too, it's not just a technology problem. I mean, the technologies have existed for a very long time. And when people tell me, oh, you know, it's so hard to keep up with security because things are changing all the time, I'm like, well, no, not really. What's happening is, okay, somebody's, you know, being better at math, right? So in terms of us or you guys who are implementing security, all right, if you're providing confidentiality algorithms, all right, so instead of typing DES, you then type triple DES. All right, well, then you use AES. you know, and fundamentally, you don't need to understand the math, but you do need to understand that, yep, you know, this will be harder for somebody to break. So there are things that are better, right? IPsec is getting better, slowly, okay? But it is getting better, and vendors hopefully are also making things a little bit easier to configure. But a lot of stuff exists out there that is really very easy to configure, can provide you a lot of security, and will keep the stupid attacks from happening. All right, so of course, when you're looking at your own networks, right, I mean, you have to figure out, okay, what vulnerability and what threats am I susceptible to, right? And in this day and age, when people, especially with the filtering stuff, filtering is controversial because every environment is different. And every time people come up with the best current practice, you know, you're hoping that 80% of the people will, you know, take advantage or will benefit from this best current practice. And then there's a whole slew of end scenarios, right, end cases, because your mileage is going to be different. So I'm sure, you know, there's going to be a lot of talk tomorrow about things. But the types of threats that you need to think about is, you know, unauthorized access. How easy is it to eavesdrop? Right? How easy is it to impersonate somebody? Spoofing packets. It's pretty simple. Denial of service, it's getting worse and worse. Viruses, they're getting worse and worse. Email spam, worse and worse and worse and worse. Right? So which one are you susceptible to? And what can you do to mitigate the attacks? You're never going to be able to stop them 100%. Okay? But what can you do as a best effort to mitigate them? And, you know, when people talk about reconnaissance attempts, I mean, it's easy and people do it all the time, right? I mean, how many times have we heard that, okay, you know, stick some kind of device out in front of your firewall and just, you know, let the log run. Like, I mean, set up some kind of filter to say, okay, deny this traffic coming in. And guess what? You know, people are doing port scans right and left. I mean, some people just have it running automatically from all over the world, right? 24 hours a day, 7 days a week. I mean, it's crazy. It's nuts. But there's a lot of bored people out there, or, you know, there's a lot of people that are motivated by money. There's a lot of 14-year-olds who are not playing soccer, but instead, you know, with their Game Boys or their laptops and, you know, saying, oh, cool, let me see what I can do, right? I mean, it really stinks. But the thing is that people do it, and you can't just say, no, it's not going to happen to me. And for people that, again, you know, watch NANOG mailing with some other ones, Rob Thomas again pointed out just recently that a lot of people are looking for Cisco routers, okay, that have HTTP enabled, right? And there's still a lot of routers that have really easy guessable passwords, Cisco. Okay? I mean, you know, I sit there and go, I can't believe somebody's doing that. But that's because I wouldn't do it, right? And I am hoping that none of you would do it. But for somebody that's a network administrator, and there's small ISPs out there, and let me tell you, I'm switching my ISP right now because I've had 2 years of, okay, this is enough, where, you know, there's small outfits, and they're like, oh, you know, I'm sorry, no, we don't have a single Unix machine, and they're proud of that. Okay? I mean, they exist, they're out there, they're, you know, maybe in your hometown. Okay? You know? And, you know, you try to educate them, and then you figure, oh, well, if they're not knowledgeable enough, well, that's okay, you know, not everybody's brilliant as me, you know. The problem is if they don't care, I have a big problem with that. And unfortunately, there are people that simply don't care, right? All they want is to provide some service, get money coming in, and do whatever they do. And, you know, that's simply how it is. But so these are the people, hopefully, you know, that have these Cisco passwords, and then I don't really care what happens to them if they go out of business. But, okay, people do it, it's never going to go away. It's just going to get worse. So war dialing, right? You think it's gone away? Nope. You know, as long as modems are around and that's the way that people can access networks, you know, that's what's going to happen. People are going to figure out, they're going to try all kinds of ways to, first of all, try and figure out, all right, what kind of equipment do you have? And then they're usually going to be somewhat knowledgeable from their network of friends and, you know, slew of chat rooms that they're probably part of to know what kind of vulnerabilities exist and then try to exploit them. So war dialing, denial of service attacks, right? So look at your favorite protocol header and, you know, there's some problem. And not everybody's going to be running the current version of everything. So there's all kinds of issues, right? Here's the packet format, just because, you know, pick any one of these segments and, you know, somebody can manipulate something and can create a denial of service attack. And the problem with the denial of service attacks, too, are that people are getting so much smarter. It used to be that, you know, maybe first of all, people would mostly use spoofed addresses. And, you know, people really don't have a lot of filtering in place. Even now, you know, even like the RFC 1918 addresses, the ones that people should use for NAT and all that, right? I mean, people don't put filters in place because, well, why should you? You know, I have to configure this stuff. I don't feel like it, right? Well, the problem is that with denial of service attacks, people can spoof packet headers, you know, and you can cause huge, huge outages of networks. And especially as they get more automated. There's a lot of automated denial of service attacks out there. And what's really scary is that I have so many people, I give a lot of these talks to corporate environments too. And it's really funny, they're like, oh, God, no way, you know, nothing's happened to us ever. And I'm sitting there going, you know something? How do you know that nobody's installed some kind of Trojan on your, you know, 10,000 computers in your environment and is not going to use that tomorrow to launch an attack? And they're like, oh. You know, because who has the mechanisms in place right now to actually figure out what kind of files are on their computer and whether or not somebody's installed it or not? Okay. Now, there are companies, there are startups that are hopefully one day going to make a lot of money because they're working on this issue, right? To make it easy for people in a computer environment to say, oh, you know, every day they do some kind of scan and say, ooh, that file, that's weird, you know, that shouldn't be there. But we're not there. We're probably a long way from being there, really. So just keep in mind, I mean, you need to understand, and especially you guys who are running core ISPs, all right? I don't care how big or small you are. You need to understand your infrastructure equipment. You need to know who has accessed that. You need to know who has modified any of the files, okay, configuration files. You really do need to have absolute control. We're becoming control freaks. So, I mean, what if a router becomes a target? They're becoming targets more often than not. And so, you know, you can disable the entire network, right? So, a lot of CPU vulnerabilities too. You can get to the router and guess what? You know, people can launch attacks to just take it down. And so, this guy, George Jones, is working on a document. It's a device security requirements document. Okay, and if you haven't heard of that, I think, you know, hopefully you will. He will talk tomorrow on a panel. And that is something where there's a lot of input that would be very useful from all of you in this room who are running networks and using devices and are really exasperated by some vendors because you have to do all this configuration where things might, you know, should maybe be default. So I encourage you to actually look at this document and provide some input. And one of the things that's in there is like stealth mode, right? Because I don't want people to know that if they've inadvertently gotten access to a device somehow, that it's a switch or it's a firewall or what it is, because then they might be able to exploit some vulnerability that I might not have had time to fix yet because I'm fixing all these other things in my network. So here are just some points to consider for a routing environment and what to do. You definitely want to limit access to routers in critical backbone areas. I mean, I think this is a no-op, right? You want to control router access. One of the things that a lot of people do is they create some kind of a group password for staff. It is much better to have passwords or, access rights for individual users. And the reason why is because if somebody leaves, right, then you have a lot less configuration stuff to do. So that's something that I try and point out to people, is that veer away from any kind of shared group passwords, because it's really not a good idea. Oh yeah, and of course I'm making the point again for the HTTP access, right, because that's happening quite a bit right now for scanning. So I have a question. All right, this actually happened somewhere, and so you've got this engineering land. There's all these people that are responsible for the backbone, and it's a NOC, and you've got all these secure servers, and got a workstation, and some people actually telecommute, but they need to know what's happening with the infrastructure. So what is a potential issue here? Anybody?
You label the engineering server secure.
Ah, very good. Yeah, okay. Yep, because nothing's really secure. Well, I didn't say 100% secure. So, mileage may vary. All right. What? No, I don't care about the firewall, although that does come into play. All right, the issue that I'm trying to point out here is that, well, that's it. Yeah, the workstation with modem, right? Because I'm like, God, I'm really important, and I really need to look at the infrastructure. I need to make sure that nothing's been modified, So every hour I got to log into my router to make sure configuration hasn't changed or something. So even when I'm home, it's a Saturday night, I need to log in. So, what's the best way of doing it? I'll just hook a modem up, to my workstation. Well, the problem is that, that's very susceptible to some kind of a scanning reconnaissance attack, right? Unless you've, configured like your reverse telnet maybe, or, your authentication mechanisms. I mean, some pretty smart little 12-year-old kid can probably get access to your network. And this all comes back to a security policy. And I know anybody who touches equipment, they're like, policy schmolicy, I hate that stuff, right? But the thing is that you're leaving yourself wide open for people to do stupid things. And I am very much a proponent of, if nothing else, create a one-pager that says, we authenticate this, we provide this for confidentiality, do not ever do this, and list your, 5 or 10 most favorite things that people do just because they don't think that it's a security issue. Because people never know as much as you do, and mostly you learn stuff regarding security through experience. And the one story I always kind of tell, and it's kind of embarrassing, but when I started working with Cisco equipment, I mean, this is 1989. And I was really curious about what it did. So one night, I'm sitting there and I did a debug all and left it on. I went home. Next morning I come in and my buddies are like running around. They're like, holy shit, packets are dropping. Mind you, we only had 5 buildings connected. There wasn't a lot of traffic, okay? But packets are getting dropped. And, I'm just getting my coffee, and I was mostly a fiber person anyway. So, I was just like, yeah, you routing people, figure it out, And it turns out that my friend Joe comes in, he goes, what the hell turned on debug all? I'm like, I did, why? Right? This is 1989. You do it today, you're fired. It was a funny story then. But people do that. So, you have these denial of service attacks that are not necessarily malicious, right? I mean, I was curious. I actually wanted to be smarter. But, I did something stupid. So you always have to kind of, just look at what people can do and make sure that, especially people who are responsible for your network infrastructure, understand some of the security ramifications. Because some things that you think are a no-brainer just really aren't. All right, so what do you do to secure your infrastructure devices? You have to just go through, okay, who has physical access, who has logical access, and what's confidential. Again, I told the story before about just a month ago, right, in Australia, there were guys that, impersonated these workers, and they ended up carrying out some kind of, mainframe, right, with all kinds of confidential information in there. So these are not just funny stories, I mean, they actually happen. So you have to really figure out, well, what do you do? And when I was at NIH, I mean, we actually built equipment closets. I mean, my boss fought tooth and nail to have specific equipment closets built in 50 different buildings where there were only 5 keys, and 3 of them were for our group, and then 1 of them was for like the fire marshal, and that was it. And it's a very hard thing. Space is really hard to come by, but you know, if it's really critical to your business, and as an ISP, infrastructure equipment is critical to your business, you really want to be a little bit anal about this stuff. You know, you don't want to say, oh shoot, I should have. Okay, and you know, I'll be the first to admit, the more you deal with security, the more paranoid you become. But I don't know, that's how it is. Anyway, so okay, physical location also, you want to figure out where you're located. If you can't necessarily get physical access, like your own, you know, space for your equipment, so you have complete control, be at least aware of who goes in the closets. Another thing that happened years ago was, you know, we shared a closet with some telecommunication folks because it wasn't yet combined. And, you know, come in one Monday and the network's down. And, you know, the building's like a mile away, so who's going to go to the building? So you try to do everything else and try to figure it out. And last of all, you know, you're like, oh, shoot, I got to actually traipse over there. Turns out that somebody had just connected a fiber. You know, it's just dangling there. You're like, what in the world? Turns out some telecommunications guy had come in, wanted to fix something. The wire was in the way. He disconnected and forgot to connect it up. You know, it happens, right? People, I mean, it sounds ludicrous, okay? But there's so many stories. So understand where your equipment is. Understand who has access. I think it's really, really important to figure out who ever either goes to the physical device, you know, whether they have physical console access, who goes into these closets, or, you know, whoever has the logical access. Because if something should happen, what you want to do is you want to have some kind of mechanism to trace back and figure out who it was or what it was, so it won't happen again. All right, for secure configurations, all right, clear text passwords shouldn't exist anymore. TACX plus and radius, most devices, some maybe it's just really recent, but they will have mechanisms so that you can keep track of authentication credentials with either TACX plus or radius. And I would strongly urge people to use this because it makes it much easier to manage. And the thing is, you have the accountability. So whenever somebody logs into a device and does something, you actually have the accounting information. And that, to me, is the most important point. So I would very strongly urge people, I mean, with your switches, your firewalls, whatever devices that you have, that you incorporate this AAA functionality for when people access your device, and mostly for logging purposes. You may not look at it for 2 or 3 years, but you know, if something ever were to happen, the logs I think will become very important to you. Also, because of input from years and years of, you know, people banging on vendors, many of them have multiple privilege levels. Some only 2, some 15, you know, whatever. But of course, it's always very good to, for the very privileged commands, to only have as few people as possible have access to that, and then kind of figure out, like, okay, who needs to know what. So I think that's also more or less what people do. I think most people at least have a 2-tiered approach where, you know, there's a few people that have access to every command and can do anything. And then there's the rest of the world that can basically just show and monitor and, you know, do the limited stuff. Encrypted passwords when viewing configurations. Most people, I think, do that. The thing to be aware of, though, is that depending on which versions of software you use on which devices, that some passwords which you think might be encrypted are not. Okay? So if you're troubleshooting something and you're sending configuration information off to your vendors, you may not have all of the passwords be confidential. And, you know, I'm talking about you have to make sure your SNMP community strings, your NTP authentication stuff, your MD5 authentication stuff for your routing. I mean, I think most vendors now in the latest releases do encrypt everything, but just be aware that, you know, they actually are encrypted. All right, I talked about Telnet and why I think it's a bad idea. Again, the reason it's a bad idea is because you do not want to send any kind of credential information, i.e. passwords, in the clear. It's too easy for people to be able to use network sniffers to get that information. And in case, you know, some people think, oh, my network's so secure, that'll never happen. Here's another story, and this is kind of sort of funny, but not really. In June, I was in New York, and I was writing this book. The editors were really getting mad at me because I'm always late, and, you know, I was like past my deadlines. So I'm visiting a friend, and I, you know, decided, oh, I'm going to use this cool gizmo that I got a year ago, but I've been afraid to use on the airplane because God knows, maybe it'll damage my computer. And I'm like, oh, I'm being so stupid, you know, nope, I'm going to use it. Find my power supply. Okay. So here I am, you know, in New York, far away from anywhere that I can get access to anything. I'll be gone for a week. You know, editors are yelling at me. Okay, what do I do? Friend of a friend works for Sony downtown Manhattan. It's a Saturday. I'm Estonian, he's Estonian, we're buddies, even though we don't know each other. So I go up to the Sony corporate network, right? And it's really funny because he left the office, right? And I'm sitting there going, wow, you know, I can actually like plug my thing somewhere. But then, you know, he left, but then he came back and he goes, Medica, you know, wait a minute, can you plug into that? Do you have a network sniffer on your laptop? And I'm like, uh-huh. And he goes, do you mind if you just walk with me? You know? So that was good. But, you know, he could have just left and not come back. And I bet you a lot of people do that, right? Because you just trust people, you know? And like I said before, my laptop wasn't working. Well, we tried to figure it out, and he gave me another battery, and that worked. So my battery had just been fried. But so, you know, if I had been any kind of malicious person, I could have sat there and said, oh, no, I don't. He might have gone away. I could have maybe tapped in, maybe looked at some stuff, and away you go. So never assume that just because your network is secure that nobody's going to ever tap in. The assumption has to always be paranoid. Somebody's going to be able to view what's on the wire. All right. Now, of course, that doesn't cover all of your scenarios. I mean, if you're connected to a switch and this is it, or you just have two devices, okay, you know, probably not. But just don't assume, because unless you have full control of absolutely everything, 24 hours a day, 7 days a week, you're physically there, you don't know what somebody else is going to do. So I'm always very careful with passwords. You know, it's I don't want to send anything over the wire in clear text. Okay, just I mean, this is obviously from a Cisco, and this is actually from a router that I had at home, and I'm going, you know, this is actually not so secure. So what's wrong with that? Forget about the telnet part. Yeah? Yeah, that's one. Okay, but yeah, no, this, yeah, yeah, line VTY, okay, it's the line VTY stuff. What's so wrong with those three lines for people that kind of have used Cisco's? No, I said not, don't worry about the telnet. Right. There's no timeout. And you know, it was funny because I looked at this and I was like, oh shoot, yeah, last week I was troubleshooting something, right? So I hate it when my console kept timing out, and I had to keep typing in my password, right? So as I'm telnetting into my router, if I troubleshoot, and I will make a bet that all of you do this, okay, you change, because of course you wouldn't do this normally, you change your timeout so it's 0, so that if you walk away to talk to somebody, your session hasn't timed out and you have to, you know, restart it again. But the problem is that a lot of times people forget, right? And they fixed it, they're so happy, it might be 3 in the morning, right? You're really happy, you're really tired, and go, phew, when you go home. And then the next morning, all you remember is that you solved the problem. but you forget that you left yourself wide open, or you cause a potential issue with, if somebody logs into the session, walks away, that somebody else might get access to the computer. So they're little things, and they might seem really, really silly, but the problem is that if you leave any kind of a window open, right, for somebody to exploit any of your devices, at some point somebody's going to take advantage of that. So as much as you can, I just really, I make people sick with, just telling them, please be vigilant. And yeah, somebody had mentioned also, enable secret password. That's all Cisco specific. If there are mechanisms where you can encrypt the password, like on a configuration, so people view configurations and they try to break the encryption scheme, always try to use the one that is the strongest one available. All right, here's another thing, banners. How many of you have banners on your devices? Okay, so out of curiosity, what does somebody near the microphone, can you say what your banner says? Would you?
It says US DoD networks.
And that's it. That's cool, that's fine, but there's two issues with that. One is if I really want to attack the DoD, then I will try to make a harder job of it. And number two, and this is very important in the US, and I think it's becoming more and more of an issue worldwide, and it depends on, your country's regulations and legislation and law and all that fun stuff. But I was told about a year ago that in the US for your devices, if you want any kind of a legal ramification or something, or to be used as evidence, you need to have the sentence that you will be prosecuted to the full extent of the law if you at some point in time want to prosecute because somebody has attacked you. And anyway, so this particular one, I decided that I named all my routers after drinks. So I then decided that, okay, what I'm going to do is just kind of say, well, here's how you make it, right? So I looked at it and I'm going, hey, I'm pretty smart. But then I'm like, no, I'm actually really stupid. Because at the end I say, get off my router. So I've told somebody that they're on my router. Why did I need to do that? Right? So you do not really want to tell people if they have somehow managed to get access to a device, what kind of device it is, because it gives them information in terms of what kind of vulnerabilities to look for and possibly exploit. And then number two is you do want to use some kind of language, and you might want to speak with your legal department so that if a security breach happens, that you have not somehow invited the person in. Like if you say something like, hello, welcome, leave now, this is unauthorized. The term welcome, because the legal system is just so wonderful in the US, can mean that, no, you were actually inviting that person into your network. Again, it seems maybe really stupid, a really silly point, but I think even things like this are going to become very important, especially if you do have some kind of a security incident and you might want to prosecute. All right, so as a checklist, I was at a session, it was at the last NANOG, and it was the security birds of a feather session that we had. And some guy just asked the question, he goes, all right, what should I do? Right, so if you can name some things that I should do to provide security, what do I do? And the answer was along the lines of, well, secure your infrastructure devices. And I'm like, what kind of an answer is that? It's very clear that, the person is asking for help in terms of what are maybe the 2 or 3 things that I should do to secure my infrastructure devices. So I like it when people actually give a little bit more information. Right, so if somebody is really looking for, okay, I've just really started looking at building my ISP, I'm still kind of new, but, and I want to now provide security, and I want to secure my devices, what are like the 2 or 3 things that I really should do? Number 1 is make sure that you control access to your devices from a console point, okay? So even when you have console access, like physical device access, put in some measures in place that say, you know, you have to authenticate with this username password, right? Logical access, the same thing. And logical access can be either your terminal line access, so SSH, it can be your HTTP access, it can be SNMP access. Allow only what you use. And again, I think I saw something on a mailing list recently where it was assumed that a certain vendor turned off the HTTP server as a default. And I believe that it depends on which version of software you are using. So, you know, and I could be wrong, but the thing is, never assume that, you know, a vendor will do something consistently throughout its software versions, okay? And as unfortunate as it may be, you know, sometimes you have to figure out, especially if you're running multiple versions of things, what are the defaults and what aren't. And just a point of caution, you know, and I think vendors should get a lot better in this to say, you know, here's our defaults so that people can be aware of what might be a security risk for them and what isn't. You want to shut down on all unused interfaces, and this is basically a precaution because it used to be that if you had them turned on, that somehow people could you know, gain access. So, or maybe even just cause a denial of service attack. So anything that you're not using really should be shut down. I would also test device integrity on a regular basis. And this is something that I don't know who has time for. Usually people outsource it. But I would try and attack my network. You know, try and attack your infrastructure. And there's a lot of people that have created test equipment, either for free or, you know, you have to pay for it, that you can just run and it can emulate an attacker. And I would do that because I don't care how smart you are, how much you know. There's sometimes you configure stuff and you're tired, or, you know, your brain just kind of goes wacky for a minute or two. And the best way to actually see whether or not you have a secure infrastructure is to try and attack it. And it's better to attack it when you know you're attacking yourself and trying to fix the vulnerabilities than if you're waiting for somebody to do something that might cause you a lot of harm. Right. So securing infrastructure devices, the main point is that any way that people can get access to it, make sure you understand it, make sure you turn off anything that you do not use. And use access controls. One thing that some people are doing, I really like this, is that they put in certain filters so that only certain equipment, let's say NOC machines, can get access to routers or switches. Now, this means that if you're traveling, you usually have to then access these NOC machines and then, you know, gain access to your infrastructure devices. But, you know, it adds a little bit of security, and some people do find that very useful. So routing protocol security. The biggest problem with routing protocol security is that the best you can do is you can just verify where the routing update came from, right? So you have origin authentication. And you can also validate that, you know, when router X sent an update to router Z, that during transit, nobody has injected any you know, bogus routing update information. But the problem comes in is that you don't know whether or not that router or that person was authorized to send you that routing information. And I liken this problem to the same problem as the public key infrastructure problem, because you have to have some kind of a trusted database that keeps track of, you know, who's allowed to send what to who, and then somehow you have to be able to get the information and validate that, yep, I got a routing update, yep, it came from that person, yep, they're allowed to send me these updates. You know, now that's getting really paranoid, of course, but I do believe that people are working on, you know, whether or not this is going to be a real huge issue in the future and how do you resolve that. But the best that we can do right now is to put in route authentication, and again, I've mentioned this quite a few times already, which is the typical MD5 authentication built into most routing protocols. Most routing protocols also allow for you to have a shared secret that's configured, that's sent and declared back and forth. You know, it's in the specs, it's in almost all the specs actually. But I believe that if anybody goes through the process of configuring their routers for authentication, then they at least use MD5. And you can also put route filters in, where you can say, you know, you should only be getting routing updates from these specific IP addresses. Now, you know, somebody can tell me, oh, well, but people can spoof IP addresses. Yeah, they can, but, you know, it takes a little bit more work. And what that also does is that may help you in case somebody does some kind of a weird configuration, you know. So how does route authentication work? Essentially, you append a signature to a routing update. And, all right, so yeah, that's what I was saying. Most of them also have plain text neighbor authentication. I don't know why people would ever use that. All routing protocols have MD5 authentication at this point in time, and just about every single vendor I know that's a routing vendor does MD5 authentication for any of the routing protocols they support. So how does it work? You have a routing update and you have a key. Remember, well, for those of you that were here earlier, you know, I went through this whole slide of a keyed, you know, hash function, keyed HMAC. This is where it comes into play. So you have a shared secret that's configured on both routers. You combine that with the shared secret with the routing update, run it through a hash function. It's typically MD5. You end up with a hash. You append that hash to the routing update and you send it. You do not encrypt the hash. Okay, it's just the hash that's sent. And so on the receiving end, you then get the routing update in the hash. You kind of hold on to the hash and keep it somewhere in memory. You take the routing update, you have the shared secret, you concatenate those, put that into the MD5 algorithm, come up with the hash, you compare the hashes. If they're equal, then you know you can be fairly ensured that the update came from who you thought it came from and the data hasn't been modified in transit. So that's essentially how MD5 neighbor authentication works. So as a summary, I do believe that everybody should turn on MD5 neighbor authentication. And again, with the caveat that you know, I still need to look at what the deal is with rekeying, because most people don't rekey because it will then cause an issue with you know, the whole routing network. So one of the things to think about and to look for in the future is whether or not it makes sense to actually use IPsec for the integrity part rather than doing MD5. Because with IPsec using IKE, you have an easier and more automated way of rekeying. All right, network perimeter. Network perimeter, right, people always talk about firewalls. And networking is so funny. I mean, people try to create new terminology to sell products, you know. And just recently, I mean, it was sort of tongue-in-cheek, I guess, but I was looking at some inter-exchange where people were saying, well, what's a layer 3 switch and what's a router? You know, well, if you put it sideways, it's a switch. If you know, put it horizontal, it's a router, all that. I mean, I think of it this way, okay? If you have anything to do with layer 2, it's a switch. If anything, you start going to the layer 3, you're a router. And I don't know whether or not it was my boss who actually came up with the term of layer 3 switch, but I think he might have. And I just remember this meeting, and we were laughing so hard because we're going, God, you know, they're selling so many of these switches because people think they're faster. So if we think a router, if we call the layer 3 switch, people will think they're faster, and they will start buying more routers again. Okay? And I mean, prove to me why a layer 3 switch is not a router. I mean, I don't get it, because the minute you look at, you know, the layer 3, you're routing. You know, you may not look at the routing table, you may look at a cache or a portion of it, but you're still looking at layer 3. You know? So, I don't know, mileage may vary. But so, when I look at firewalls, right, and I sit there, I'm like, okay, so what's a firewall? And I'm like, well, it's something that can filter. You know, and mostly something that can probably filter at layer 3. Right? At least at layer 3. Because usually you don't look at something that can just filter MAC layers or MAC addresses as a firewall. But anything that can say, okay, permit, you know, this packet that has this IP address, and maybe you will look deeper into the packet and say, and this port number, and something else, you know, and either permit or deny it to happen, that's a firewall. And I believe that, you know, firewalls came out of, well, if you had a router and you had filters, there was a point when it couldn't scale anymore, right, because you were taxing the CPU. So people created these separate devices so that you could do real in-depth packet, you know, look in-depth into the packet and make some kind of decision, because the deeper you look into the packet, right, the more CPU cycles you take. So rather than take away from a router that was forwarding, right, a layer 3, you then had a separate device that did it. So anyway, the firewall, you know, it's filtering. And stateful firewall is, well, you know, there's some protocols, or the deeper you look, you need to know, well, if I sent you this and I sent you this, you know, I have to keep track of that information, right? And that's the stateful firewall, because you can't just throw one packet away. You have to look at a communication as a whole. So terminology to me gets really funky. I mean, sometimes people are like, oh, you don't really get it. I'm like, no, I do. I don't like your terminology because you're confusing me. You know, let's get to the basics of what it really does. So, all right, filtering. I was driving people nuts at a conference or a talk that I gave in Taipei in February, because every hour I would say, what's the word of the day? And they're like, filter. You know, because people still do not filter. People do it more now. And I think it's because people just keep mentioning it over and over and over again. But there have been a couple of RFCs written within the IETF that just recommend certain best practices. And you should always, always, always put some kind of a filter in, I think, at least at the edges of your network. And of course then it's like, okay, what is my edge? Well, you know, that mileage can vary as well. But the closer you are to the customer, right, that's where you should filter. And there are some things that really are no-brainers. I would very strongly urge, for those of you that either are not filtering, I don't want to know who you are, look at this RFC, okay, and at least implement this filtering. There's another RFC, a draft that's written by Bill Manning, and he lists a bunch of more addresses that really should be filtered. And I have that in one of my slides. But, you know, I'm sort of hoping that vendors will do it. I know that some vendors do it, okay, that by default they filter the really silly stuff, all right, so that if you are in a NAT environment and you have a 10 dot blah 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 address, that you don't propagate traffic to the real internet using that address. Because even though it might not go more than one hop, you know, you're still causing issues with that one link, and if that link is shared by a whole bunch of people, that could be a denial of service attack. You know, and so, anyway, I think filtering is really important. And again, you know, here's a header format, right? People, I mean, this is typically what you filter on. You filter on source and IP addresses for layer 3 and the protocol type. And then if it's TCP, right, you look at the port number, destination and source, or UDP, same thing, destination, source, port number. Logging filter port messages properly. Logging is always interesting because how much do you log and what do you log, right? And that, again, depends on how you've created your filters. you need to be very careful about, when I look at filtering, what I think about is, okay, if somebody has attacked my network and I need to figure out who it was or what it was and make sure it never happens again, what is the logging information that I need? And also, how much logging information do I need so that I will actually look at it? Right? Because if you have reams and reams of data, you just kind of go, oh yeah, whatever. Right? And I mean, there are, hopefully, there are products, there's things people have cobbled together so that they can have a better way of viewing the logs and have an understanding of when something happens. Mostly, I believe that these things are starting to get called intrusion detection systems in some way, shape, or form. But you really, logging is interesting because there's all these questions of, well, what do you log? Do you need to know what interface it came into? Depending on what device do you use, how much is it going to affect your CPU, right? And anyway, so my tendency would be, if you create any kind of a filter, you always want to allow things that you know and deny everything else. And then I typically log everything that I deny because I want to know why somebody's trying to get access to something that they really shouldn't. So that's just one thing to think about. All right, so this is just some recommendations, and these are sort of the just template filters that are the no-brainers, where you should never have a loopback interface or any of the RFC 1918 networks going out from your corporate network out to, your whatever, your upstream, right? Now for you, I mean, since you're service providers, I mean, this is more at your customer end. And then, the thing with ISPs that's so interesting is some people have control over their customer networks or the edge that's on their side, and some people don't. So, what do you do and where do you put your filters? And what I always say is, well, with security, it gets interesting because if you have, again, the horrible word policy, what you do is you try to adhere to that policy with whatever you have control over. And of course, whatever isn't a performance impact. So you may actually want to put in some kind of a filter going or in the interface that's coming in from your customer, because you can't trust them to actually put in the filters in place. And now, again, that also depends on whether or not it's really going to be an issue for you or not. And that's where the controversial part comes in, because why create a filter if it's never going to be an issue? So it'll be interesting to see what comes out of best current practices. I don't know how many of you have seen that, but there is some interesting fight going on right now, because apparently the IAB has, made a statement that that it's a bad thing for ISPs to filter, things like, the Microsoft port numbers and all that, because it breaks applications. So that's true, but what do you do? Right, because if your customers aren't filtering, then you're leaving your core open to, these horrible denial of service attacks, or these viruses that keep propagating. So if you're doing filtering, and I believe all of you should do it at some level, the ordering is important. What sequence is the packet inspected in? And most implementations have a sequential way of doing it. So you actually want to be aware of what your traffic is, so that most of your traffic hits the first number, first 10, first 20 entries. People used to always say, God, I have such a big performance impact on my filters. And then in some devices that, if you had like 500 entries, sure, if all of your traffic kept traversing all of them and basically they matched at, entry 498 and 499, of course you're going to have a performance impact, so reverse it, right? Some equipment vendors don't have that issue, so that's great. Okay, what else is there? Remote access. I'm not going to talk too much about this because we got to go. But remote access, I mean, again, it's mostly to your customers. Do you have VPNs? do you do SSL or IPsec? The one thing that you need to figure out, and you really need to understand what it is that you want to do, is that if you have, let's say, a customer or somebody coming in remotely, and you have a VPN, and you're trying to figure out whether or not you want to use SSL or TLS or IPsec, remember that anytime that you poke a hole in the firewall, okay, and let's say that, you know, you really want to understand your traffic, and you have a stateful firewall, so you want to know what the negotiation is back and forth for whatever you can keep state for. Anytime you poke a hole in the firewall for SSL or TLS, you know, you're bypassing that policy, right? And so it's becoming more of an issue where, well, what do you do? And so I sometimes like IPsec more, simply because the way that I would design a network would then be that I would actually have some kind of a VPN concentrator, you know, some device that has a lot of CPU that can do the decryption part or encryption part for my IPsec, and then send the traffic to a firewall so that my firewall can still pick up what kind of traffic is going to the rest of my network. Now, you know, there's no best current practice for that, because really it depends on your particular environment. But you have to do the trade-off, and you have to think, well, what is important in your environment, and what do I care more about, and what do I have more control over? And, you know, I do this when I look at any network device too, or when I build networks, forget even about security. My biggest question always is, all right, the device works, great, well, it's supposed to work. If there's a problem, how quickly can I solve the problem? You know, what tools are available for me within that device or so? And it's the same thing with security, right? It translates completely over. So yeah, you know, I'm configuring these things, I think I'm secure, I'm supposed to be secure. Now I have an attack, you know, now there's an intrusion. What is the quickest way for me to, first of all, try and figure out where it's occurring and to stop it? You know, it's a pain. I mean, that's what makes security hard, right? Because you really have to think, I mean, about a lot of things. And it's all about risk mitigation. So you're never 100% secure. All right, mitigating DDoS attacks. Again, filtering will mitigate some of the really stupid attacks, right, where addresses are spoofed and somebody's really lazy and just using spoofed addresses. Directed broadcast traffic. I mean, hopefully most vendors actually do have that off as default. But if you're using certain versions of software, especially for Cisco, right, some older ones don't have directed broadcast turned off, so you have to specifically define that. Permitting only traffic that's necessary and denying the rest is the best way to go, the securest way, but it's also a big pain in the butt. So even though, you know, that's what I say, hey, you know, do this, you know, it's really not practical for all environments, and especially in ISPs, because, you know, you're just basically, you're supposed to let all these people just communicate with each other, right? You're not the traffic police. But you have to be very vigilant in terms of, you know, what's happening, what kind of vulnerabilities are out there, what your customers are doing, and whether or not you can trust them to do the right things. So this is from Bill Manning's RFC. This is basically the filtering that he recommends. And again, most of it is the just addresses that should never be seen on the public internet. Reverse path forwarding. Those of you that have attended Barry Green's presentation, he talks a lot about black hole filtering and reverse path forwarding, which is a really good way to actually maybe try and ensure whether or not a packet that's coming in to an interface, okay, whether or not the source address is reachable from that interface. So it's a sanity check. So if you can, and if your devices support that, whatever flavor you have, you know, it's probably useful to turn it on. But also remember that it could be problematic in asymmetric routing environments. So just some tools for detecting DDoS stuff, and we're out of time. So what I'm going to do in the next, you know, after dinner and all that, I'm going to talk a little bit about things to think about in terms of auditing, and, you know, what kind of tools are available, what kind of things you should keep track of, And I'm also going to have some sample configurations for kind of templates. Like here, if you have a switch, if you have a firewall, if you have a router, you know, what are the no-brainer kind of security things that you do need to actually configure, because unfortunately they're not default. Okay. And again, just as a closing for this particular portion of the session, I encourage you all who have not yet read George Jones's draft. If you don't know him, you'll see him tomorrow. Ask him where you can get a copy, because the draft that he's trying to put out through the IETF is a security requirements one, which hopefully will also help vendors, the non-clued ones, that you know, these are the best practices for what you should incorporate in your devices. So that way you guys don't have to do all this god-awful configuring to, you know, make your devices secure. All right, thank you.